Hello and welcome to Section 4 of Chapter 2, titled Finding Maximums and Minimums of Polynomial Functions. Now, this is just Part 1. Now, in Part 1, we're only going to talk about quadratic functions. The graph of quadratic functions look like parabolas. Now, the maximum or the minimum value always happens at a special point called the vertex. Always happens at a special point. Now, to compute the vertex, you need to find the x value first. That formula should look familiar. Again, the vertex, if you have a parabola that opens down, is at the top, and that means you have a maximum. And if you have a parabola that opens up, you have a minimum. The vertex is an ordered pair. It's x comma y, but the fancy way to write it is x is opposite of b over 2a, and y is whatever you get when you plug in opposite of b over 2a. It's whatever you get when you plug in x. That's to find the maximum or the minimum value of the vertex. Jumping into the first example, read along with me. And now you should have this paper that I gave you in class. A rectangular dog pen is constructed using a barn wall as one side and 60 meters of fencing for the other 3 sides. Find the dimensions of the pen and give the greatest area. That's the maximum area. Also answer the question, what is the domain? Now remember, the maximum occurs at the vertex. The maximum occurs at the vertex. That's where it always occurs. Alright, here we go. So we've got a barn, but that counts as one of the sides. And then we've got a rectangular pen. Now, rectangles have 2 sides. They have a length and a width. We'll just call the side that's the same, we'll call that x. Now, the area for a rectangle is length times width. Okay, our function is going to be the area in terms of whatever x is. So the length or the width is just x. But what is the other dimension? What is the other side right here? Now remember, we only had, 60 meters of fencing. And how much have we used so far? Well, we've used 1x and 2x's. So what we have left over is what we started with, 60. Take away the 2x's that we've already used. That's what the other side must be. So down here, the width is 60 minus 2x. And if you wanted to, you could distribute that. That'd be negative 2x squared plus 60x. All I've done is turn it around. That is your function for the area in terms of x. Write that down. Function for the area in terms of x. I'll say it one more time. Function for the area in terms of x. Now the maximum area occurs at the vertex. That's what we're interested in. Now since we have a negative leading coefficient, this parabola is going to open down. And we want to find that maximum area. Now the x value of the vertex is the width that gives us the maximum area. Well, we can compute that. We know how to find the x value of the vertex. Negative b divided by 2a. Alright, opposite would be, now that we have our formula, is negative 60 over 2 times negative 2. That's negative 60 over negative 4. That's positive 15 meters. The value of x at the vertex that gives us maximum area is 15 meters. Well, now you can find your dimensions. Well, we just found the width. It's 15 meters. The length, well, take this 15 and plug it into our formula for the length. It'd be 60 minus 2 times 15. Well, that's 30 meters. Alright, so now our dimensions, width was 15 meters by 30 meters. Those are the dimensions that maximize the area of this pen. The area of that pen. Plus, when you add them all up, 15 plus 15 plus 30, you'll get 60. Those are your options. And then finally, find the domain. Now remember, For domain, you're asking yourself, what values of x are you allowed to plug in? What values of x are you allowed to plug in? And remember, domain for length, it's got to be positive, and width has to be positive. You can't have negative length and negative width. So it's real simple. For width, all we used was x, so x must be greater than 0. Done. We know x has to be greater than 0. For length, we use 60 minus 2x, and that's got to be greater than 0. Remember, this was our length right there. We'll solve that. Pick up the 2x and drop it off on the other side. Turn that around. X must be less than 30. Alright, so there's our domain. Let's put it together. All x's such that it's got to be bigger than 0 but smaller than 30. Anything beyond that interval, if you plug it in for your formula, you're going to get negative areas or impossible areas. Alright, you're not allowed to have negative areas. So there you go, guys. First thing we did, review, we came up with our equation. Then we did x opposite of b over 2a to find the value of x that maximizes our area. Then we were able to find our dimensions right here, and then we found our domain. Let's do one a little bit tricky. This is number 2. A rectangle has perimeter 50, so all 4 sides add up to 50. Find the maximum area of the rectangle, and what is the domain? Find the maximum area of the rectangle, and figure out what the domain is. Well, first thing we need to do is come up with our equation. So let's call one of these sides, just call it x. Now we're using all 4 sides here. We're using all 4 sides. But we only have 50 centimeters to work with. Well, what's left? 50 centimeters is left. Take away what you've already used. You've already used not 1x, but you've used 2 x's. But wait a minute, we have to deal with 2 sides here. So this is only half of what's left, so you must divide this number by 2. So this side actually becomes 25 minus x, and this side is also 25 minus x. Did you catch that? We said, okay, they must all add up to 50. We've already used x and x. So start with your 50, take away what you've used, the 2x, but then cut it in half because you also have this side up here. Alright, now remember, area in terms of x equals length times width. Well, that would just be x times the 25 minus x. Here's our formula. That would be negative x squared plus 25x. Booyah! Check that out. Now that you got your formula, this is smooth sailing from here. Alright, here's the question. To answer this question, they want the maximum area. Do they want the value of x that maximizes the area? Or do they want the maximum area itself? They want the maximum area itself. So they don't just want the x value, they want the y value. Remember, y is the same thing as a of x, and that means area. That means area. But before you can have a y, guess what? You must have an x. And to find that x, you have a handy-dandy little formula, opposite of b over 2a. And here we go. So the opposite of b would be negative 25, divided by twice negative 1. That's 12.5 centimeters. That's the value of x that maximizes the vertex. That's the value of x that maximizes the vertex, but that's not what I want. I want the maximum area possible for this rectangle right there. So what do I got to do? I got to pick him up and plop him in for x to find the value of x that maximizes the area. So a of 12.5 would be negative parentheses 12.5 squared plus 25 times 12.5. And when you type that into your calculator, you're going to get 156.25 centimeters squared. That, my friends, is the maximum area that you can get. That's the biggest you can make that rectangle with a perimeter that has 50 centimeters. All right, let's find the domain. In other words, what is x allowed to be? Well, again, for the width, we said the width was just x earlier, so we know the width, the x has to be bigger than 0, has to be positive. Well, that makes sense, because if it was negative, this rectangle wouldn't exist. And the length, what do we use for length? Oh, here it is right here, 25 minus x. So put it right here, 25 minus x. That's got to be a positive number too. Well, just move your x over. Turn it around. X must be less than 25. So our domain, I'll bring it over here, is all x is such that it's got to be a positive number. It's got to be bigger than 0. But it's not allowed to be bigger than 25. As soon as it's bigger than 25, then the same thing's going to happen. You're going to end up with a rectangle that doesn't exist. Think about it. What if x was 26? Well, 25 minus 26 is negative 1. And last time I checked, I've never seen a rectangle that has a side length of negative 1. Alright, sweet. Okay, let's try this one. Suppose you have a fence 108 meters, say you have 108 meters of fencing to make 2 side-by-side rectangular enclosures. What's the maximum area you can enclose? And again, what's the domain? Well, we're going to do the same thing again. Okay, but we need to have, instead of just 2 x's this time, we have 1, 2, 3 x's. 3 x's. Okay, what do we have left over for the length? This was the width. I'll put w equals x. For the length, remember, we started with a total of 108. But what have we used so far? Take away the 3 x's that we've used so far, but we've got 2 of these sides, so we got to cut that in half. That's our length. That'd be the same thing as 54 minus 1.5x. That means this side is also 54 minus 1.5x. Now that we've got our length and our width, let's write our formula for the area. It's the width times the length, 54 minus 1.5x. Distribute, I got negative 1.5x squared plus 54x. Now go back and read the question. It says, what's the maximum area you can enclose? Not the value of x that gives the maximum area. They want the maximum area itself. So, we need y. Need y, but before you can do that, must have x. So, before we can do that, negative 54, this is opposite of b over twice a. Opposite of b over twice a. Let's see here. That's negative 54 over negative 3. That's positive 18 meters. So that's what x is that gives you the maximum area, but it's not the maximum area itself. You got to plug it in. Plug it in. You like my singing, don't you? Okay, so put that there. Negative 1.5, 18 squared, plus 54 times 18. Answer, 486 meters squared. Dog, right there. There it is. 486 meters squared. Notice I put meters squared. And again, let's find the domain. For the width, we said the width was just x. So again, x has to be a positive number. We're kind of seeing a trend there, aren't we? And the length was, is this nasty thing right here. 54 minus 1.5x. That's got to be a positive number. 54 minus 1.5x. So, add 1.5x to this side. And divide by 1.5. X must be less than 36. So this time, the domain, the values of x that are allowed, any x such that it's got to be bigger than 0, but smaller than 36. Those are the values of x that are allowed that will give you a rectangle. Anything beyond 0 or 36 will give you negative lengths, which, again, that's impossible. Alright. Number 4. A ball is thrown in the air from a building 30 meters tall. Might help us to draw a picture this time. A building 30 meters tall. So here's my building. Look at my building. Isn't it cute? So that distance right there is 30 meters. It has an initial velocity, or vertical velocity, of 25 meters per second. Its approximate height on the ground, t seconds later, is given by this formula right here. This formula right here. After how many seconds does the ball hit the ground? I even gave you the answer. Looky there. It's 6 seconds. After how many seconds does the ball hit the ground? But let's figure out why that is. So here's our ball. It starts out at a height of 30 meters. Put a dot right there. And then it goes up, whoop, and comes back down. And it reaches a maximum height up here, a maximum height up there. This is when its height, in terms of time, is equal to 0 when it comes back down and hits the ground. Alright, this point up here, that's the vertex. In letter A, we want to know when does it hit the ground. So, first thing we're going to do is substitute our 25 for v sub 0, that's our initial speed, and our 30 for our h sub 0, that's our initial height. Here we go, part A. Now, in part A, I want to know when it hits the ground. When it hits the ground, so the height's going to be 0. That's negative 5t squared plus 25t plus 30. Well, since it's set to 0, we can divide everything through by negative 5. Divide everything through by negative 5. In fact, why don't I just pull it out? So that gives me t squared minus 5t minus 30. So t minus, what multiplies to 30? Wait a minute. No, when you divide, I'm an idiot. When you divide 30 by 5, you get 6. So it'd be t minus 6 times t plus 1. So t could be 6 seconds, or t could be negative 1 seconds. And the last time I checked, your name is not Marty McFly, and you can't go back in time. So 6 seconds is how long it takes the ball to hit the ground. How long it takes the ball to hit the ground. Alright, let's move to question 2. What's the domain of H? And here I gave you the answer, 0 to 6. 0 to 6. In other words, what values of t is t allowed to take on? What can t be? What can t can be, now I'm using t instead of x here, right? This is domain. T can be anything bigger than what? Can t be negative? Can we have negative time? No, t has to be bigger than 0. But then t has to be smaller than what? When did it hit the ground? Well, it hit the ground right here at 6, 0, at 6 seconds. After 6 seconds, the ball goes below the ground. Well, that's impossible. That's impossible. And that's it. That's the only way to do B. You just kind of got to think about it. You got to know what domain and range are. And then how high does the ball go? How high does the ball go? Well, that means we want to know its vertex. Now, do I want the time that it takes to get there, or the actual height of how high it goes? I want to know how high it goes. So I want the y value of the vertex. I want y. That's what I want. But I must have x first. Well, we know how to do this. We've done this several times. Opposite of b over 2a. Let's see here. That'd be, go back to the original. It'd be negative 25 over 2 times negative 5. That is 2.5. So it takes 2.5 seconds to get to the maximum height. 2.5 seconds to get there. But now how high does it actually go? Find h of 2.5. That would be negative 5 times 2.5 squared plus 25 times 2.5. Just going back to the original equation, plus 30. And that answer, my friends, 61.25 meters. Meters. 61.25. I put it up there. That's my vertex. That's how high it goes. That was saucy. I like that problem. That's an important problem. Guarantee you're going to see one on a quiz or a test. Okay, and then the last problem, I typed this out for you just because I knew this video would be getting a little lengthy, and I didn't want to have to write it all out. I figured I could talk through it more quickly. Here we go. The Indianapolis Star has a circulation of 100,000 papers, and it sells for 50 cents a copy. It decides to raise its price because the company costs increasing. It finds that it will lose 10,000 readers. Lose 10,000 readers every time it raises its price a quarter. Every time it raises its price 25 cents, it loses 10,000 readers. What price per copy maximizes income? Well, remember, income is just the number of copies you sell times the price per copy. The number of copies you sell times the price per copy. Let's see here. Let X be the number of 25-cent increases that it's going to do. The number of 25-cent increases that it's going to do. So we start off with how many people it had. It had 100,000 people, but then it loses 10,000 people for every increase it has, for every X it has. It loses 10,000 people for every X increase. The price of the paper was 50 cents, but it gains 25 cents for every increase. Gains 25 cents for every increase. And then I just did FOIL, and I got me a nice quadratic equation here. Income in terms of the number of increases. Here's my nice quadratic equation. Find the maximum. Opposite of B over 2A is 4 increases. The 4 increases will maximize the income that the newspaper gets. 4 increases. Now remember, it started out at 50 cents. Plus 25 cents times the 4 increases that it needs to do. 25 cents times the 4 increases that it needs to maximize its income. That total, that new price that they wanted, what price per copy, is $1.50. That's how much it should sell its newspapers for to maximize its income. And folks, I think we have maximized all I'm going to get out of you for this video. Hope you have a great night. Watch this video a couple more times, or at least one more time whenever you're studying for your quiz or your test. Hope you had a good time. I'll catch you later. I'm out.